Okay. So the first 10 questions of the exam, I'm going to describe to you a business situation. That business situation is listed on your exam review sheet. So there are 2 exam review sheets. One is sort of content-based, the things you must know for the exam. So going through the slides. Another one is sort of a practice sheet. So on the practice sheet, there at the very top, there is a scenario. And that scenario is a company has designed a new logo, and they run some sort of A/B test to see if their old logo is better or their new logo is better than their old logo. And so your task for the first 10 or 12 questions will be to sort of consult them on that experimental design. Okay? So I was watching this last night. Kids were watching this last night, and I saw that. I'm like, oh, that's a really interesting A/B test. Maybe we could talk about that in class tomorrow and critique it, and it'll prep us for the exam. Okay? So I'll go ahead and turn that on. We'll watch it, and then we'll come up with some smart things to say about it.
Illusion is cool. What if you could
Yes?
Was that their last time?
It's new. I got a new. So if you're noticing, I have a new toy.
Yeah,
It's
I heard this buzzing, and I'm like, what is that?
Yes. So there's a camera. It's called the Swivl robot, and it records lecture. It's terrifying
Well,
too.
the fact that it literally follows your every movement.
It does. I have a little thing. I have a thing in my pocket that it tracks. So it's not super smart
It's a
and
little less creepy.
okay. Well, don't let it creep you out. So then if we miss anything today, still try to take the best notes you can, but if you miss anything, hopefully there'll be a video for you to reference. This is the first time I've tried it, so we'll see how it goes. Okay, but first let's do this exercise. I think it'll get our thinking in the right place and be good prep for the exam, actually.
trick your mind into not feeling pain? Sound impossible? Now you know how to access your super pain resistance power. Watch closely. First, we're going to see how long participants can handle the torture of ice cold water. Then we're going to test a simple hack that may give them, and you, super pain resistance. Ready? Here comes our first volunteer. Well, that certainly looked difficult.
I feel like I just went outside with no gloves.
And our other players didn't do any better.
It's really cold. Okay, I can't do it anymore.
Now, do you think there's anything that can help them more than double their time? What if we let them wear something to shield them from the cold? No, not those. One of these. They're putting on their biggest smiles. Research shows that smiling can actually help you withstand pain. Sounds crazy, right? Let's see if it works.
Super smile!
Remember, all these kids could only handle the ice water for 9 to 12 seconds the first time. Ready? Go! Wow, all these people almost doubled their previous time. So it looks like smiling actually helped.
When I smiled, I could handle the pain a lot better. It was weird. It felt like when I smiled, I could keep it in there for a lot longer.
But why?
I was focusing more on smiling and my hands, so it lasted longer.
Imagine that! By using the superpower of smiling, your brain's attention was distracted from the pain. There is another way to activate your anti-pain superpower that we can't quite put into words.
My name is out the way!
So why does swearing work?
I think because I was was able to fight the cold with my words.
But really, any kind of yelling works.
Ah!
But we suggest you just grin and bear it. And don't worry, this guy wasn't really cursing in a crowded mall food court.
Wow, that kibble! People jacket! Oh my!
But not only did this challenge unlock the power of smiling, it also exposed another hidden super.
Alright, the other superpower is not so interesting. Okay, so find someone in the immediate vicinity. Have a quick chat about this study. Here are some suggested discussion topics, points. Why is this study bogus? Why is Netflix feeding my kids garbage science? Between subjects, within subjects, effect size, sample size, generalizability was something that came up. The mechanism, mediation, moderation, all of these topics that we've talked about in here during lecture are relevant to this study. So let's see if we can apply what we've learned to some sort of experiment that we would encounter in the real world. All right, go. Or on a test. I wish this was the test. If I could give any test, I would have to say this smart thing about this. If you get to 10, you get 100%. All right. Yes. Good? Questions? Concerns? Oh, generalizability. So that we talked about in sampling, the extent to which we can generalize results of one study to a larger population, to which it applies in other situations. How are you guys doing? What'd you come up with?
Well, it's BS because of the fact it's focusing on anything. Like anything can distract you, not just smiling. And then also there's four young girls who obviously have crappy pain tolerances, and then one man.
And then we said I forget which is which, but basically they should have split it up so maybe like some people smile and only smile and some people don't smile. And see what happens.
Yeah, so that would be the between subjects option. Yeah, so here they did a within subjects design, right? So, and also you're describing the smile, it's not so much the smiling, it's the distraction, it's the mechanism, right? So it's not really about smiling, it's about distraction, because also shouting works. So that's a good point, and that gets at the mediating effect. So smiling causes you to be distracted, and that's what causes you to have higher pain tolerance. It's not like it makes you happy or something. It's about being distracted. So, yep, so that slots into mechanism. And Elizabeth's comment slots into between versus within because they're doing within subjects, but she says it would, or suggests it might be better to do a between subjects design. Yeah. All right. All right. Ready? You guys ready to say some stuff? Okay. All right. What'd you guys come up with? Devin.
We had a couple. So,
Okay.
one, so like Claire mentioned that because like the first time they did it, they were kind of like, I don't know, it was like surprised the first time they do it, but the second time they were a little bit more used to it, and they also want to do better the second time they do it. And then I said that it's really just anything that you focus your mind on other than the ice water, so it doesn't have to be smiling or yelling, like you could be frowning or like keeping your mouth open or, you know, trying to focus on solving like a Rubik's Cube or just anything that you're focusing your brain away from the pain of the hand. So it's not, it could really just be anything.
All right, so where does that slot in up here?
So it's a within.
It is a within subjects design. Right, so so everybody first put their hand in without smiling, then they trained them to smile while they were doing it, and then they did it again. So we could call that a repeated measures design, a pre-post design, a within subjects design. That would be the technical name for what that's called. So it is within. So that slots in there. What about your comment about why it's happening? Where's that slot in up here? You said it's happening because it's distracting you, and even solving a Rubik's Cube would also distract you. Anywhere up here that comment slots in?
The last one.
So you described the mechanism, right? So the mechanism is like why something works. So we talked about mediation versus moderation. So mediation is why something works. Moderation is when it might work better or worse, right? So what Devin was describing is that, well, yelling also works, and probably solving a Rubik's Cube would work, and smiling also works because the mechanism is that whatever that thing is distracts you from the pain, and that's what lets you keep in there longer. So that's the mechanism or the process by which the phenomenon works. So when we try to think through, these kinds of issues, we think about mediation. Why is this happening? Right? Why does swearing also work the same as smiling? Obviously, swearing, maybe it's not because your smiling makes you happy and you're happy to tolerate the pain. It's because it's distracting you. That's the engine that's driving the effect. Yeah.
Why something works and moderation is it has to work better.
Better or worse. Right. So mediation is the engine that it works. So why we get from A to B. And moderation is when that path from A to B might change. What's some other variable that might come down and change strength or direction of that effect? Okay? Somebody else give me something that they talked about in their group. So we have Bruce?
They use the same hand both times.
Yep. So how do you feel about that?
So when you put it the second time, your hand's probably already still cold from the first time. So it's probably not much of a temperature change.
So Bruce has suggested this is, I think, slots into this one, right? He has an alternative hypothesis for why, it's not that they smiled. It's that when they put their hand in the second time, their hand was already cold and numb, and so it didn't bother them as much. It has nothing to do with smiling or frowning or cursing. It's just that every single time we had first they received no training or no smiling, and then they had smiling. So we talked about that when we talked about experimental design in terms of a confound. So a confound is any time we change more than one thing between the two conditions. Right? So in this case, we've changed no smiling, smiling, but we've also, at the same exact time, in parallel, first, second. So if they can hold their hand in longer the second time, is it because it's the second time and they've just gotten better at it for whatever reason? It's numb. Or is it that actually the smiling works? Good. Any other thoughts? Any other things you talked about in the groups? What about the sample size? How do you guys feel about the sample size? Keely?
How about age?
Okay.
In that they could be more easily convinced that that was what they were supposed to think or say because they're not necessarily our age older.
Okay. So we have a couple of things in this unpacked. So one is that they're more easily convinced. So it looks like kind of like they were told during the study that, if you smile, you'll be able to keep your hand in there longer. If I tell someone the hypothesis that I'm trying to prove, what's the outcome of that? Remember what we call that? And they do it. They do what it is we demand them to do. It's called a demand effect, right? So when we sort of cue people into what we're trying to do, they just say, okay. Oh, if we smile, we're supposed to keep it in there longer? All right, I'll do that, right? And so Keely is saying, well, 12-year-old kids probably would be convinced that it could work. And so it's not really about, it's a demand effect. It's not even a distraction effect or a numb effect. It's a demand effect because we told them what was going to happen. And they complied, which is a problem with experiments and research in general. Whenever you sort of give people an idea of what your hypothesis is, they may just say, okay, well, I'll do that then. So what we want to do then, and so especially in this kind of case, which is a within subjects design. So remember, within subjects design is where everybody is exposed to all conditions. Like, okay, we're going to have you do it once just normally, and then we're going to have you do it again smiling. All of a sudden I know, okay, you're studying the effect of smiling. That's clear to me. So then the question is like, well, do I keep it in there? Is that a good thing or a bad thing to smile? So then we have a demand effect problem. Okay, so that's a weakness of within subjects design where everybody sees all the conditions. With between subjects, we would have two different groups. One group that was just smiling and having their hand in water, and another group that was not smiling and having their hand in water. And then we would calculate the averages of those two groups and compare them. It's okay. Just because the camera is going doesn't mean you have to be super quiet. But good. Let me get deep. How do you guys feel about 12-year-old boys and/or girls in that? Actually, I think one of them is a boy, but in the last one, everyone said it was all girls as well, which is kind of interesting. Just for like that. Where's the one that has them all?
Well, that certainly looked difficult.
I feel like I put outside, looking over them.
And our other players didn't do any better.
That guy.
It's really cold.
What? No. Anyway, I digress. So, but just veering into psychology for a bit. Like we had seen two girls, and so our mind is primed to expect another girl, and then we see someone with long hair that fits our schema for what girl's hair looks like, and we automatically assign them to girl category, and then we move on to the next girl. So that tends to happen. There's a lot of studies in psych where they do that. They kind of get your mind primed to see things in a particular way, and then they show you something, and you just slot it into that spot. Anyway, not going to be on the exam, so let's talk about how 12-year-old kids might, how do you feel about that in this particular study? Yeah, very good. Okay, so then kids are more, so do you have a problem with testing this effect with kids? You think it's still a good test or no?
I don't think you can generalize it.
You don't think the results will generalize to the adults? Okay. Okay. Devin, do you have a thought?
I also think that, so like, I feel like there's a lower pain tolerance for like younger kids, because like, I don't know, like when I was younger, I don't know if I used to get like a scrape and like spray some of that stuff on it, it used to hurt like a lot.
Mm-hmm.
Like now that I'm like older, like it doesn't hurt as much, or like if I'm going to get like a cold shower, I'm not like, I don't know, as dramatic about it because I don't know, it's just something you do. So I feel like just having like the exact same, age kind of limits the amount of experience they've had.
Okay. So, yeah.
There's also like different pain levels, so that probably doesn't fit with all. Like if there's something more painful, smiling.
Oh, like something that's super painful, and smiling is not, like if you're on fire, smiling is not going to help. Yeah. Okay. Let's say I think this will be a useful exercise. Let's do, because on the exam, you will have to, so what we're coming up with moderators, right? So we say, okay, the effect of smiling depends on something else. So let's just, as best I recall, the kids started out, they were kind of a mean of about 9. So here's kind of where they were. The mean was right around 9 seconds, right when they were not smiling. And then after we did the intervention, their mean was like up in the 20s. Right? So that would look something like this. And we're all pretty tightly clustered too. Right? So this would be, if we were to run it, if we were to plot this out, this would what the data would look like. We would have some situation where we didn't have them smile, so we would represent that with a 0. We would have a situation where we did have them smile, so we would represent that with a 1. Their scores would stack up over the top of this, and then we would calculate the mean and compare those two means. Okay? So get with someone in a group and come add a theory to this. So you can add Devin's theory about younger people being different, having different sensitivities, or Emily's theory about, some situations, it's not going, the pain is not going to, it's not going to help in some situation, which you might call a boundary condition, and sketch that out. So the idea is that I have some theory about the way the world works. Could I depict that theory on a piece of paper?
The y-axis is how many seconds you can hold it in, and the x is
Yes. So we would put our independent variable on our x-axis and our dependent variable on our y-axis, right? And so our independent variable here is our manipulation. We had a pre-condition where we didn't tell them to do anything, then we had them smile, and then we have a post-condition where they're smiling with their hand in water. And here, they on average, there's a little variation, but it was between like 8 and 12 seconds where people were, about 9 for the average for the 4 kids. And then when they were doing the smiling, they were averaging more around the low 20s. So that would be a mean, and pretty tightly around 20. Okay? So this, if just looking at it, this is what the data would, it's my best guess of about what the data would look like in, if we plotted it out. So draw another line on there. So draw this out on your piece of paper and draw another line in that represents some theory that we heard or that you have about the way the world works. And then the question is, would that line that you drew represent an interaction? So as a tip or a reminder, we know when we draw these lines, we know it's an interaction if the slope of the line is different. Remember, when we think about a moderator, we have some relationship and some other variable plops down on that path that knocks that line either flatter or raises it up, knocks it up from the bottom, or flips it all the way together. There's some other force. So the effect of smiling on pain tolerance depends on this other third variable. That's how we talk about a moderating variable in real world language. So you have to know, I think that's on the exam, knowing what the real world language for moderating effect is. It would be the effect that we're looking at depends on this third variable. The effect of studying depends on how much sleep you've had. The effect of how much water on whether or not you have to go to the bathroom or not depends on how much exercise that you've had. So Bruce's example from last class. Right? So draw in a line, and should we have people come up to the board and share their lines? Sarah's like, yes, I want to come up to the board and share my interaction. So on the exam, there will be stuff that looks like this, and you'll have to interpret it. So you might as well get your head around it now. Or there'll be...
So does the moderator intersect, or does it just like make it new lines?
It's a new line, a second line. What's a so you draw another. So this is for the kids. Kids and ice. This is what the effect looks like for kids and ice. Maybe you could do it for adults and ice, or maybe you could do it for kids and fire. How long will you stay in the fire? If you're smiling. I'm guessing that would look like this. We would call that a boundary condition. I am not willing to be burned for any amount of time, no matter whether I'm smiling or not. Right? So that would be kids and fire. I'm at 0 seconds of being burned in both the smiling and non-smiling condition. We would call this a boundary condition. We have crossed some pain threshold whereby smiling no longer applies. Okay? We also had a theory that adults might be different and that their pain tolerance might be higher. So they would be their action would be happening somewhere up here. The question is whether or not it would be an interaction or not. Yeah.
So say if you're doing something like adults, but after you hit a certain age, then your pain tolerance is going to go down. How would you draw that out? Like for instance, like my grandma probably wouldn't be able to hang in there very long. I mean, she would, but like
yes.
Relative, like maybe in like 10 years, she's not going to hang in there.
Okay. So we could conceptualize it as, if we wanted to do that, we could conceptualize it as 3 groups, like, like adults, elderly, and children. Or we could, technically, we could just treat that as a continuous variable in a regression. But for the purposes of graphing it out, we'll just think of it as, we would think of it as 3 different lines.
So would that be a moderating variable?
It would be a moderating effect. So some other variable that comes in and changes this in some way.
Could I do like this? That's what I was thinking. Like I was thinking like people over the age of 55, they wouldn't be able to start out as high, but they wouldn't go up as high even.
Okay, so it'll be as okay. Mm-hmm.
It's like not as drastic, if that makes sense. It might go up like a little bit, but not like.
Yep. So that would be an interaction. Yep.
Okay.
Could you do where they live? Like
you could.
I mean, like if they're from the north, they're probably like more tolerant.
Okay. Yeah.
So the mediator's smile. But
The
the moderator is whatever other line or factor that you could do that would like go against before that.
The mediator is what the smile does. So if the smile distracts you, then it's the mediator would be distraction.
Okay.
Then the moderator is the strength.
It would change, so you've changed the strength of the effect, right? So it's not as strong as an effect for elderly people.
Could for this one, could the moderator be like how much ice you put in there? Like, could they like put more ice in it if some of it was melting?
I think, well, technically speaking, it does. If there's ice in it, it's still 32 degrees.
Okay.
But I think, but that would. So that would. What would that do? That's a good. I don't know if that would change the slope or not.
Like if it was straight ice between ice and water.
Yeah, like a straight block of it.
Does the time matter as much as the difference in time between? So it doesn't matter where they're like. It doesn't matter how long they keep it in there. It's just the difference in time between each thing. So could you technically just pick a group and then examine that group, and then it's like you have to pick somebody who's like from Antarctica versus somebody who's like from Florida. Does that make sense? So it's just as long as it's one same group, as long as they're from the same place, same age, whatever, and then you can just test different.
Or even if they weren't.
Even if they weren't.
Yeah.
As long as it's different.
All right. So anyone want to describe their theory, and I'll try to draw it up here on the board. Bruce.
Old people.
Old people.
Okay, like age, but then higher and lower.
So we'll just say elderly people are more or less sensitive to start with. More sensitive, so they're going to keep their hand in for longer. Is the smiling going to work for grandma? She's not. Not grandma. So grandma maybe will get a little bump from the smiling, but not as much. Where the kids are super susceptible to our suggestion, and grandma's a little more doesn't believe it, maybe. All right. So here is a subtle interaction, but it's an interaction. So here's the effect for kids. Grandma starts off lower and then doesn't increase very much. So the fact that the effect is not as big for grandma as it is for kids. Okay. Let me give you another potential. Let's say we had, college age people. What if it looks like this? Is this an interaction? The effect is the same, right? It's parallel lines. The effect is the same for college kids as it is for kids. They just start out in a different place. So this is not an interaction. This has two main effects. We have an effect of smiling and we have an effect of college. And these lines are going in parallel. But the effect of smiling doesn't depend on, so that's how we say an interaction. The effect of smiling depends on whether or not you are a kid or a college student. The effect is the same. It doesn't, but the effect does depend on if you're elderly, because here the effect isn't as big for the elderly people. So this situation is not an interaction. This situation is an interaction, because the effect has changed depending on what type of person you are. Here it's just we start out in a different place and move everything up. So an interaction, so circling back around, thinking about interaction, it's a situation where we've changed the strength or direction of an effect. Okay? So when you're looking on the exam, if you see lines that are parallel, that's not a good candidate for being an interaction. If you see lines where the effect is changing, either slightly or maybe it goes like this, then that's a good candidate for an interaction. Here's the strongest interaction you can get is when it goes this way sometimes and goes that way other times. There's situations where it's good for some people and bad for other people. All right. All right. So, and that's the strongest. So this is when you're looking at I'm not going to ask you to draw lines this year to avoid technical difficulties, but I will put a bunch of lines on there and say I'll give you some theory and I'll give you like 4 or 5 of these to choose from and say which one best represents the theory that I just described to you. And if I say there's no interaction, there's just between the effect of smiling on ice doesn't depend on whether you're in college or kid, that looks like this. If I say, oh, it's good for some people and bad for some other people, that something like this. If I say which one is the strongest moderate, which really looks like a moderating effect, it could be anything where could look like that. Anytime where the paths are going in opposite directions. It changes the strength or direction of the effect. A boundary condition, like fire, that's a situation where we cross some boundary where the effect can no longer live. You're in some space, some situation where the effect can no longer live. So if I describe a theory where, well, this only applies in this situation and not in this situation, this is the not situation, some flat line. Okay? So you'll just have to kind of be able to get your head around. So if you can draw them, you can interpret them. So like we've been doing in class, if you can draw them out, you can interpret them. Okay. So that gets to, and so that over there is moderation, a third factor that changes the strength or direction of the effect. The mechanism or the mediating factor is why the effect works in the first place. Right? And so the mechanism, the reason why smiling works, they suggest in the video, is that it distracts you from the pain. But then because it's confounded, we also can come up with other mechanisms. Oh, the kids were just trying to please the experimenter. Oh, their hand was numb. Right? Whenever you confound things, you can come up with different explanations for why it happens. Okay, so one way around this issue of confounding it would be to go let me just finish up with generalizability. Do we care that this is, if we're looking at the effect of, so whether or not how concerned we are with the fact that these are 12-year-old kids depends on our view of the world? Is our view of the world this, where the effect depends on what age you are or some other variables, like where you live or how old you are or demographics? If it does, if we have a strong theory that, oh yeah, it really matters, like what age you are, or if we're like, no, like college kids may be more pain tolerant, or people from Alaska may be more cold tolerant, but we don't have a strong reason to believe that the effect of smiling on pain tolerance differs for college kids or teenagers or people from Alaska. If we don't have a strong theory about why the overall effect of smiling, going from 0 to 1, not smiling, we don't have a strong theory for why that's the case, then we should be okay with the kid sample. If you recall back to the first section of the course where I had that example when we talked about sampling, where my wife was doing the study in the mall where they had people holding the hot cups, and then the test was, their theory was that their cup was a better insulator, and that so people could hold it longer comfortably. It's like it maps onto this perfectly. Right? They were in a mall, they were having people hold something uncomfortably and put it down while someone timed them. And then they replicated that study like in 6 different places across the country so that they could have generalizability. And I was like, so you think that people in Florida have different heat sensitivity than people in Texas? She was like, no, not really. I'm like, well, you just wasted 30 grand then, because that's what you set yourself up to be able to test. So if we don't think that the effect of smiling should be different for kids than it is for college students, then we should be good with college students. Okay? All right? Or either one. We should be with either one. Okay, so that's generalizability. We talk about mechanism and moderation. Sample size. Is this a big sample? 4 people? It's a super tiny sample. What about the effect size? Do you have an intuition for if this is a big effect or not? I'll tell you it's a giant effect. I'll just tell you. So doing some small intervention, increasing someone's performance 100%, that's like huge. Like in marketing, usually what we're dealing with is we'll be able to, by some marketing intervention, we'll be able to move someone from like a 6 to like a 5.5 on some 7-point scale. That's like usually the best we can do in marketing. Here we've doubled our performance. Like that's huge effect. And also the results were super consistent. So here they were almost always between between 8 and 12, and here they were almost always between 19 and 22. So this is a huge effect, and it's super consistent between the groups. What does that mean for our sample size? We need a big sample size in these conditions or a small sample size in these conditions? Small, right. Because what the test is going to say is remember a p-value is how likely are we to see an effect this big and this consistent by chance alone. That's essentially what it's telling us. And so the bigger the change and the more consistent it is, the less sample size we need to get to that p-value of we're after. Okay? So on the exam, there will be a question where it will describe something as either a strong effect or a weak effect. And you will have to know, do you need big samples or small samples? If you're going to do something subtle, that's going to likely to only have a very small effect, you need huge samples. Because to show something when something is subtle or the results are all over the place, then you need big samples. Also relevant to this, which is better also on the exam, which kind of study has more power? Which kind of study design, between subjects or within subjects? Confer with someone in the immediate vicinity and see what they think. Between subjects or within subjects?
Did you say which one has more design?
Which has more power? Which design has more power? So between subjects this was a within subjects. We had both measures happened for everybody. So each participant was exposed to all the conditions. With between, we would have had 2 groups of people, one that only smiled and one that only didn't smile. Each condition is only exposed to one level of the manipulation.
So it would be within would be the most powerful.
Yes.
Now is that just because like the same there's less variability between like individuals? Is that where that comes from?
It's important. The variability is evenly spread across the groups. Okay. All right. Did we land on within? Because on the slides, there's a picture of the Hulk on the within. That's to show that that design it's a super strong design. Okay, it's powerful. And the reason is that any outliers or any weirdness of people gets spread equally across the two groups. So imagine we had somebody that was like super sensitive to cold. They couldn't stand it at all. They weren't going to keep their hand in there for even a second. And we did a between subjects design, and we randomly assigned them to the smiling condition. Even though we said they should smile, they don't care. They're going to go boop and be done with it. That's going to bring this mean down, right? It's going to, because it's an outlier. However, if that is reflected in, if that kind of tendency is reflected in all the conditions, then it's equally represented in both the groups. So they'll bring both means down, but hopefully at the same rate. So the effect itself will still be protected. So you'll come across a situation on the exam. The scenario is in this A/B test. We can only get a small sample. Should we do between or within? If you can only get a small sample, you may want to maximize the power by going with a within subjects design. Because a between subjects may not give you enough power to show differences in a reliable way. Okay? How are we feeling? Good? All right. So I'm working my way up. So yeah, within, so continuing within and between. So the strength of within is that it's more powerful. The weakness of it is that people, because they see every possible condition, they get a pretty good idea really quickly what your hypothesis is. So they see, they're like, here's what we're going to do. We're going to have you put your hand in the bucket not smiling, and we're going to have you put your hand in the bucket while you smile. Right, pretty quickly, they can infer that this is a study about whether smiling makes me keep my hand in the bucket longer. So now what can happen is like, oh, well, what's the right answer? Is the right answer I should keep my hand in the bucket longer when I smile? If it is, I'm a nice, young, compliant person. I'll go ahead and try my best to do that. That's a demand effect. So within subjects design, the weakness is people will figure out what the study is about, and there's the risk of a demand effect. The demand effect is when they just give you what they want. We're not after what people think we want, we're after the truth, right? So with a between subjects, you don't know that there's other people smiling with their hand in the ice bucket. You only know that you have your hand in the ice bucket regardless of smiling. Okay, so it's very stealthy, hence the picture of the stealth bomber on the slide. It's sneaky, and so you can get less your results will be less biased by demand effects. And okay. So now that we've had a discussion about this particular study for a while, I might just run through. Does anybody have any questions? Take a break. Why don't we do a check-in? Just like turn to someone in your vicinity. We talked about a lot of stuff. Confer with someone. Well, I didn't really get what he was talking about with within subjects. Compare to a notes check, where you guys check your notes. We'll do that for like a minute or two, and then I'll just launch into a review. Yeah. So it'll be regression output will be on this, and you'll have to know how to interpret the regression output. Which
it's like part 4.
Yeah, show me how to create a dummy variable by 0, 1. Yes, this is just a previous year's question. I will give you. So this one, regression here. That's 4 on this one too. Interestingly enough. Yes. So you still have to know how to interpret. So all this stuff is still relevant.
Okay.
What a p-value is.
But what did you say was going to be on the test, like with regression, like specific question?
There'll be output. You'll have to interpret the output. Yeah, this time I'm not going to have you generate the output.
But you'll give us like the Excel thing, and we'll have to tell you like what kind of like interpreting it is, like just like what we did on the last test. Saying like what's important and magic p-values, maybe 0.05 and 0.1. Okay.
All right, everybody checked in with their peers, and any remaining questions that you weren't able to resolve with your peers about what we just went over? Okay. Now I'm going to zip through the review sheet kind of in order. Okay, so the Dunning paper, please read that again. There'll be a question on that. Make sure you know what the sacrosanct belief is. That'll be on there. Make sure you know that presents an alternative view of marketing whereby people first make a decision and then figure out how to rationalize that decision. So if you reread the highlighted parts, you should be good to go on the Dunning paper. There's a version in Canvas that's highlighted. So a spurious relationship. So we talked about the ice cream causing drownings and the fire truck causing damage. Understand that basically the idea is correlation does not equal causation, does not prove causation, and that's kind of the whole point of experiments. Because with experiments, what we do is we, as the researcher, supply the cause. Up to now, we've just been measuring stuff out into the world and looking at the extent to which it correlates, which two variables correlate. Here, we're bringing someone into like a lab setting and doing something to them, manipulating them in some way. So that means we are supplying the cause, and if we observe differences, say between our group A and our group B, and we randomly put people into those groups, we have a strong case for saying what that thing that we did caused that difference to happen. Because we brought them all in, randomly put them in two groups, did different things to the groups, and then observed a difference. Probably we can make a strong case for the fact that the thing that we did caused the difference. That's the whole notion of experiments, is to rule out this kind of correlation versus causation thing, because you supply the cause. Okay? All right. So that's the philosophy behind experiments. And so because that's the idea, when we create these experimental manipulations, we want to be particularly sensitive to avoiding confounds. So a confound is when we change more than one thing between the conditions. So in the slides, there's that kind of stereotypical example where we have two different versions of an app, and we were doing an A/B test on them. And one of the apps is purple color scheme, and one of them is a gold color scheme. And also the purple one is vertically oriented, and the gold one is horizontally oriented. So if the purple one does better, why is that? Is it because it's purple? People like purple better? Or is it because it's vertical? We don't have any way of knowing, because we've changed multiple things at the same time. So when we observe that difference, we have no strong case for saying which one of those changes is responsible. It could be purple driving the effect. It could be color driving the effect. It could be layout driving the effect. So if we want to make a case for why something is happening, the mechanism behind something, then we want to only change one thing at a time. This is why experiments are inherently more limited than something like a survey research, where we can measure a whole bunch of stuff and essentially look for a whole bunch of correlations. Okay? You can only really have one or two things that you cause to happen at a time in order to say what's going on. All right. If your manipulation is very subtle, big sample sizes. If we do a between subjects design versus within subjects design, bigger sample sizes. And what we want is, the idea is that we want to, when we run our stats, we were looking for a p-value that shows is less than 0.05. All right, so p-value will tell us in this case, what's the likelihood we would see a difference between our A group and our B group this big by chance alone. Okay? That's what it'll do. This big and this consistent by chance alone.
And which one did you say smaller sample size for between or within?
For within.
Within.
Because between we have the possibility of getting an outlier in one of our groups, somebody who's particularly extreme on some characteristic, and they'll throw the results off. So in order to counteract that, we have to make our sample sizes bigger. Okay? So on the exam, there'll be something like, you expect that the difference between these two logos is not very, very big. It's a small change. Do we need bigger sample sizes or smaller sample sizes? Well, if it's a subtle change to the logo, we need bigger sample sizes to show that that's a difference. We're expecting these means, whatever they are, the effect to be very tiny. So we need more evidence of that. All right. Demand effects. So we talked about if you have super obvious manipulations are good, but we talked about demand effect, whereby if someone knows the purpose of your study, you're paying them to participate in the study, then they'll sort of give you what you want. More generally, anytime you clue participants in to the outcome that you're expecting, they won't answer honestly. They'll just give you the outcome that you're looking for, which is not what you want. So in this scenario, if you really wanted somebody in the test, if you were testing two logos, you designed a new one and an old one, and you really wanted to know which one was better, because you know your business kind of depends on having an attractive logo, you probably wouldn't tell people, oh, here's the new logo, I really like it. Because people will go like, oh, yeah, that's great. Right? If you do that, you're telling people what you want to hear, and they'll just tell you what you want to hear. So don't clue people into what you want to hear when you're designing an experiment. You want honesty. And sometimes the way to do that would be make sure, there's a number of things you could do. You could do a between subjects design so they don't know there's two logos. Or you could not tell them which one is the new logo so they don't know which one you're hoping wins. Right? You could then counterbalance the logos, showing them half the people you show logo A first, and the other half you show the new logo first. Devin?
So if you're doing a between study, would you still be able to be honest with the fact that you want them, like you could just say like we're starting to see like how well you like this logo since it's between and they don't see the other one, so would you say that you could be more honest in between or more honest than in between?
Can you be more honest in between subjects? It's just, you would just say we want people's opinions of this logo. Right? You wouldn't say, hey, we have some other people over there doing another logo and we want to see if yours wins or the other one wins. You would just say, hey, we're asking people to rate a logo. You want to do anything you can to avoid biasing people in any one direction is the key. All right, so that's through group 3, which is condition assignments, the advantages and weaknesses of those two. Everybody feel good about condition assignment? Between versus within, what they're good for? Order effects, also we did order effects with the ice. We had an alternative hypothesis that the reason for the effect was an order effect. We also had the vodka example from the slides. People are going to like the 5th vodka a lot better because they're in a good mood rather than the 1st vodka. Okay. Oh no. Do you need to run to the restroom and dry off your laptop? Okay. Feel free. Okay. All right. So moving on to point 4 on the review sheet. So point 4 on the review sheet talks about regression. So I'm not going to have you power up Excel and generate regression this time. I'll just give you regression output from experiments and show that you need to be able to look at it and interpret it. So when we analyze data there may be a question on how, there may be a multiple choice question on how we use regression to analyze data from experiments. So if you did the classroom exercise successfully and watched the video and can do the practice exercise, then you should be good to go with that. So basically what we do is we take say we have an A/B test. What we do in our data, so we'll have columns that look like this, right? Some people thought if we had a between subjects design, half the people would see A, half the people would see B randomly. Right? What we do is we create a new column, maybe A01, that will look like this. This represents our A/B test in this 0, 1 dummy variable, where 1 represents the absence of something usually, 0 represents the absence of something, and 1 represents the presence of something. And as we've talked about in here, essentially all the stats we're working with is just some lines in a space. And in the case of experiments, that line goes through the mean of the two groups, the A group and the B group. And then what our regression will say, when we analyze this with a regression, we'll get an intercept value in the output. So an intercept is where the line intercepts the y-axis. That is the mean value of our A group. Then we'll also get a beta coefficient for our 0, 1 variable. That tells us when we go from 0 to 1, how much do we go up? From a 1 unit change in x, from 0 to 1, what's the change in y? So the logic of it is exactly the same as it was when we did regression in surveys. When we go, a 1 unit change in x results in a how many unit change in y. And in this case, say the mean was 5 here and 7 here, then our beta coefficient, it's called coefficient in the Excel output, would equal 2. So if we wanted to, right, it would be the change in y that results from a 1 unit change in x. And here we're always dealing with a 1 unit change, going from A to B, 0 to 1. So you need to be able to look at that and say, and then this will have a p, this coefficient will have a p-value associated with it. And then you'll say, well, how likely is it we observed an effect of going from 0 to 1 was this big by chance alone? So if the line looks like this, the coefficient might be like 0.03. That means that the mean here is 5 and the mean here is 5.03. What's the likelihood we would see a difference this big by chance alone? Probably pretty likely. We're in the hundredths of a point, right? It's a very small change. Likelihood this would happen by chance alone? Pretty high. So you have to look at the p-value and see, is this change due to chance alone, right?
So for the exam, will all that be provided to us? Or
You'll have Excel output, just like you would generate yourself. And I'll describe the experiment, and I'll give you, here's the Excel output, the regression output from Excel. And then I'll ask you a series of questions.
Be short answered, I guess, where you just type in like.
I might say, what's the mean of the A group? The group coded as 0. And you would look for the intercept. I would say, what's the mean of the B group? And you would look at the intercept, and you would add the coefficient to it, and to come up with the B group. What's the likelihood that this difference happened by chance alone? You would look at the p-value next to that coefficient, and you would say, oh, well, it's only a 0.001 chance that this happened by chance alone.
Now, we have the table, like when you run the regression, where you have like the coefficient, and you have like the effect sizes for each one, and then 2 columns over you.
I'm just going to give you straight up regression output that Excel generates for you.
Yeah, okay, so with the blocks and all that, like what we've looked at in class.
Mm-hmm.
Okay.
Yeah. So. Okay. Anybody? Why don't we? You want to check? Why don't we do a notes check? Check in with somebody in the immediate vicinity. See if you are on the same page about what you need to do with regression. Yep.
When you say A group, will it always be like the first group that's going to just have the intercept?
It's whatever group is coded as 0. So whatever group you decide to make 0, that's the group that will be 0, that will be the intercept in the output. So you make some decision. Like, so you have an A group and a B group. You decide which one of those you want to be 0 in your data, and you decide which one is going to be 1. So whichever one you decide is 0, it's kind of arbitrary, or sometimes there's a natural fit. So like in the example, probably not smiling would be 0, because it's absence of smiling, and smiling would be 1, because it's the presence of smiling. That's, if you have two ads, you know, an ad in Jamaica versus an ad in Florida, it's not really clear which one you should code as 0. So you would just pick one, and that would be your intercept. Good question.
On the assignment 3, this could you just put up some info, but like I remember we did like A times B for the third column.
Yeah.
And, like if it wasn't 1 and 1, it would be a 0, more or less. If it wasn't like both of them going on at the same time, is it going to be like that? Or 'cause I noticed that one.
So on the video, if you looked at the video for the homework, I had a little more time, so I got into interaction effects. So the way to test for an interaction effect, so if we were looking for some different slopes, would be we would have 2, 0, 1 columns, and we would multiply them together and put all of these in the regression equation together. That would be more. I don't think we didn't have enough time to go over that in class. I'm not going to test on it.
So, but for the
unless it's an extra credit kind of situation.
But for the exam, like it won't be like the interaction. It'll just be like if they're smiling for 1, then it'll be 1 for A, B, the third one.
Yeah. So let's keep rolling with our. Let's say we also had a condition where it was Alaska, or they live in the Arctic. So our B 0, 1. That was our second factor. So if we were testing a 2x2 kind of situation, then we would create a third column that was A times B. So this would be 1. This would be 0. This would be 0, 0, 0, 0, 1, 1. We would take the product of those two and put all of these in the regression together. And then this one would tell us the test is if those slopes are different. So if the slopes look like this, where they're parallel, the effect of this is going to be statistically insignificant. If the slopes are looking like this, where they're quite different from each other, they're more likely that this is statistically significant. We didn't really get into that, so for the Excel output, I'll just have an A/B test. We ran out of time a little bit, but that's how you would do it. Okay. Any other questions on how to interpret regression output? Confidence intervals. Confidence intervals are going to definitely be on the exam. We're not going to draw them this year, but I will give you some and interpret them. So remember, as I like to say, 90% of marketing research is looking at 2 bars and telling which one is higher, and then making some managerial decision based on the fact that that bar is taller than the other one. If that's 90% of what we're doing, then we should have the best possible tools we can get our hands on for making that inference. Is A taller than B? No? It could be. Looks like it is. Are you feeling super confident about that? Not right now. He's like, I don't know. Maybe it is, maybe it's not. That's the right answer. It's hard to say. What makes it easier to say is if I put confidence intervals on it. What if my confidence intervals looked like this? Is B taller than A? It is not. Because what the confidence interval says, like, I went out and collected a little bit of data, and based on the amount of data I collected and the variation in that data, I can say with 95% certainty that the true population mean is somewhere in this range. My best guess is that it's this, because that was mean. But based on the number I selected and how much variation was, I'm only really willing to say that it's somewhere between here or here. For this one, same thing. So the true population mean for A could be that it's here, and the true population mean for B could be that it's here. So does this give me a strong case for saying that B is taller than A? No. It gives me no case for saying it. It just says I didn't collect enough data. What would happen if I collected a lot more data? My confidence intervals would shrink. Why would they shrink? Do you know? Not less variability. The variability could even go up. You have more confidence because when we collect more data, we have more confidence. What are confidence intervals built out of? Plus or minus 2 standard errors, right? And the reason we use standard errors to build our confidence intervals is because in that equation for how to compute a standard error, the sample size is in there. For standard deviation, it's not in there. Standard deviation just measures how much variation. But standard error incorporates how big of our sample sizes. So as we collect more data, our ability to estimate how precisely this represents the population mean gets better and better. So what about if we had something that looked like this? Now are we ready to say that B is bigger than A?
No.
No?
There's a higher possibility.
I'm okay with it. So this picture, this approximately is equivalent to a 0.05. So in your slides, there's a slide that looks something like this that's important for the exam. So I will give you a bunch of bar charts and ask you to tell me, whether B is taller than A. Like on your practice sheet. So here's what this says. Based on this picture, we would say that there's a 5% chance of seeing a difference this big and this consistent by chance alone. Standard error incorporates how consistent the data is as well as how much of it we've collected. So how likely is it we would see a difference this big and this consistent by chance alone? And this picture looked like. This is a particularly relevant picture because when there's an overlap of about 1/2 of the bar, 1/2 of one bar is overlapping, that about equals 0.05. Let's say we collected some more data. Or let's just say that group A was super consistent. Like the data didn't bounce all over the place. There are no outliers. And now the bars are just touching. Feeling better or worse? Even better, right? So this picture, where the bars are just about touching, is roughly equivalent to about a 0.01 situation. So if we look at a picture and we see bars that are just touching, we're like, there's about a 1 in 100 chance we would see a difference this big and this consistent by chance alone. So without these, we have no idea of how confident we should be that this is a real difference. What the confidence intervals, they tell us. In this picture, I know exactly. I'm like 99% sure this is a real difference because there's only a 1 in 100 chance I would see something like this by chance alone. While we do, this is definitely be several questions on the exam on this, so let's do a quick notes check on that and make sure everyone's clear on everything with that. Okay.
many questions?
Relatively fewer, because all the ones in this section, all the short answers are like use some outside program, like a drawing program or Excel. So it may skew more towards multiple choice than normally.
But we will have to use like an outside program.
Yeah.
So that one, is it that you're 99% confident that he is solving the
So this is a p-value. So these are p-values. So I would interpret it using the language of p-value, which is there's a 1%. Our hypothesis is that B is bigger than A. There's a sort of 1% chance that we're wrong about that. Or another way of saying it, there's a 1 out of 100 times we would see a difference this big by chance alone. So when you say how confident you are, that verbiage is more relevant to the confidence intervals themselves. We're 95% confident that the true mean is between here and here, and we're 95% confident that the true mean is between here and here. And because of that, there's only a likelihood of 1 in 100 chance that we would see this by chance alone. Mediation and moderation, are we feeling good about that? When we went over, we did a lot of that with the example. Any last questions? Show of hands, who's thinking about tomorrow versus 1, 2, okay. Okay, so a half a dozen people. So meet here during class time tomorrow if you want to take it tomorrow.
Can we do the 8 a.m. too?
If you want to come at 8 a.m., come at 8 a.m. I'll have an 8 a.m. section and our 9:30 section. You can come to either one. Sure. All right, if I don't see you tomorrow, have a great spring break. Be safe, have fun, and we'll see you back in a week.
Can we take it tomorrow? Do we have
What is this?
No, let me.
Yeah, I thought that.
Are you sure? That seems so wrong. He goes, it's